All right, so for number 3, we have 3 equations. I'm going to go ahead and number these just to help keep us organized. Okay, so I'm going to number them as equations 1, 2, and 3. Obviously, 1 is the first equation, 2 is the second equation, 3 is the third equation. So using some common sense here. So this is 1, 2, and 3. And we need to take our system of 3 equations into a system with just 2 equations. So we need to combine some things together so that we can eliminate a variable, and we only have 2 variables left with 2 equations. So looking at the way this is set up now, we need to decide if we want to eliminate x's, y's, or z's. And I would recommend anytime you have something with a coefficient of 1, that's the variable you end up getting rid of, because it's easier to manipulate stuff if there's a 1 there. So looking at this problem, which of these variables has a coefficient of 1 somewhere? The y. So y is going to be easier for us to eliminate. It's going to require the least amount of work. All right? So if I want to eliminate y, then I need to combine 2 of these equations together to do that. So which 2 equations would you like to combine together? 2 and 3? That won't help me.
1 and 2.
1 and 2 will help, because combining 2 and 3, it doesn't, I could do that. Let me say that. It's not wrong if I combine 2 and 3. You just are causing more work for yourself. Okay? We want to use equation 1. So, but if I want to combine 1 and 2 together so that I can eliminate something, then what do I need to multiply equation 1 by? 3. If I multiply this by positive 3, then 3 times 2x is 6x. 3 times negative y is negative 3y. 3 times negative 3z is positive 3, let's try that again. Negative 9z. And 3 times 1 is 3. So this is still equation 1, by the way. It's just a different form of equation 1, but I'm going to label that as equation 1. And I'm going to combine that with which other equation? 2. So 4x plus 3y plus 2z equals negative 4. And this is equation 2. So if I combine these 2 together, what's going to happen to my y's? They're going to cancel out. So let's start with my x's. I have 6x and 4x. That's going to give me what? 10x. My y's are going to cancel because negative 3y and positive 3y cancel out. I have negative 9z plus 2z. What is that? Negative 7z. And then I have 3 and negative 4, which is negative 1. So now we have created which equation? Equation 4. So we have made up equation 4. We didn't really make it up. We created it by combining 1 and 2. All right, so now we're going to do that same process again. We need to create another equation with just x and z in it. So I need to combine 2 equations from my first 3 again. So let's see, I'm going to rewrite my first 3 equations, and you don't have to, but I'm going to. Okay, so I'm going to rewrite my first three equations. That's what I'm trying to say, which are 2x minus y minus 3z equals 1. 4x plus 3y plus 2z equals negative 4, and negative 3x plus 2y plus 5z equals negative 3. And again, these are equations 1, 2, and 3. So I need to combine 2 of these together now to get rid of y again. And I had a great question in my last class that said, why do you have to eliminate y both times? I was like, that's a fair question. So we're going to come back to this in just a second. So imagine that the first time I had eliminated y. So I got, what did we get for that first one? 10x.
Minus 7z equals negative 1.
Okay, so the first time we eliminated y. So let's suppose the second time we did some math and we eliminated x. Well, if I eliminate x, what 2 variables am I left with in my equation? Y and z. So then let's suppose that I end up with 4y plus 3z equals 4. Well, can I actually do anything with that? Can I combine these 2 together to get rid of something? No, because I have different variables there. So each time, the first time I'm doing this, to get my equations 4 and 5 have to have the same two variables in them. So I need to do something. I need to combine two of these equations together to eliminate y again. I can't do 1 and 2 again because I've already done 1 and 2. So that would give me the same thing I already had. So what else could I do? I could do 1 and 3, or I could do 2 and 3. Does it matter? No. So 2 and 3 is going to require me to do a little bit more work. 1 and 3 is going to require the least amount of work. So if I wanted to combine 1 and 3 together and eliminate y, what would I have to multiply equation 1 by? A 2. So I multiply all of this by 2. Then 2 times 2x is going to give me 4x. 2 times negative y is negative 2y. And 2 times negative 3z is negative 6z. And 2 times 1 is 2. This is still equation 1. It looks a little bit different because I multiplied it by something, but it's still equation 1. And I'm going to combine that with which other equation? 3. So if I combine it with equation 3, so negative 3x plus 2y plus 5z equals negative 3, which is equation 3. Well, I can combine these together. So what happens, let's see, what about my x's? If I combine these together, what does that give me for my x's? 1x. So I get 1x. What happens to my negative 2y and my positive 2y? They cancel. And then negative 6z plus 5z is negative 1z equals negative 1. And now I have created which equation? 5. I'm going to tell you, getting here is the hardest part. Getting to this point is the most difficult part of all of this. But if you can get here, you're going to be fine, because from this point forward, it's pretty easy. All right, so now that I have equations 4 and 5, which both have two variables, then we can do elimination on those. But that part's easy because that's the part that we know how to do. We've already worked with that. So help me out because I can't see my equations. The first one was 10x minus 7z, 10x minus 7z equals negative 1. And that first one, the second equation, equation 5, what does that one say? X minus z equals negative 1. And you can put that 1z or you could not put the 1. It doesn't matter. It's the same either way, just clarifying. So now from here, I need to do the idea of elimination again. So I either need to get rid of my x's or get rid of my z's. This worked out really nice because both my x and my z have a coefficient of what in equation 5? They both have a coefficient of 1. So, and again, this is equation 4, this is equation 5. So if I'm going to eliminate something, then I need to multiply by something in order to make that happen. So what do you guys want to multiply by? 10? Would it have to be a positive 10 or a negative 10? Okay, negative 10. If I multiply this second equation by a negative 10, then what can I eliminate at that point? The x's. Okay, could you multiply by a positive or by a negative 7 and eliminate the z's? Yes, either one's going to work. They're both going to give you the same answer ultimately. So negative 10 times x would be negative 10x. Negative 10 times negative z is positive 10z. And negative 10 times negative 1 is positive 10. Which equation is this, by the way? 5. It is actually still 5. It's just a manipulated form of 5. But it's still the same thing we had. It's like the same equation. We just multiplied it all by negative 10. Okay, and then I'm combining that with equation 4, which was my 10x minus 7z equals negative 1. And now we just get to do math. And we get to do easy math on this, which I'm very glad for. And I know you are too. So if I'm doing easy math here, okay, what happens if to this negative 10x and positive 10x? They cancel. What happens with 10z and negative 7z? 3z. And 10 and negative 1 gives us 9. Look, so what's z going to be? 3. See, wasn't that easy? Yeah? You can say that. So we divide both sides by 3 and we get z equals 3. So how much of my answer is this? It's a third of my answer because my answer is an ordered triple. That means there is an x value, a y value, and a z value. They do go in alphabetical order. There was a question about that this morning, so just addressing that. They go in alphabetical order, just like an ordered pair does, x and y. So now that I have z, which I know is 3, what do I do to find y or x? Which one can I find first? X. Why can I not find y at this moment? I would have to have x and z in order to find y. And the reason is because when we look at our equation with two variables, like this one, my x minus z equals -1, and I can plug in 3 here for z, and that's going to help me find x. So that's the equation, by the way, that I would pick to find z, or to find x, I'm sorry, because it only has, like, no coefficients, and the only numbers it has are all negative, so it's not terrible. But that equation was x minus y equals -1, correct? Was that what it was? X minus z, I'm sorry. X minus z equals -1, but we know that z is what? 3. So x minus 3 equals -1. This is equation 5. This is equation 5 right here. So I picked equation 5. You could either use 4 or 5.
So we can't plug it into the original 3.
You cannot plug it back into the original 3, and this is why. So if I plug in, because at this point all we know is z, correct? So if I plug in a number for z, how many variables are still left in my problem? 2. That doesn't help me find either one of those.
But if we found x and we had both of them?
Yes, if we had x and z, then we could plug that back into the original 3 and solve for y. Okay? So I'm going to plug z, what I found out, into one of the original, or into either 4 or 5, which we picked 5 because that one's easier. So what do you do to get x by itself here? Add 3. So I'm going to add 3 to both sides. And I get x equals, what is -1 plus 3? 2. So that's my x value. So now I know my x value of my problem. So I know x, I know y, I know z, I'm sorry. And how do I find y? You plug x and z into either 1, 2, or 3. So look at 1, 2, or 3. I want you to pick one. I don't care which one you pick. You're going to pick 1, 2, or 3, and you're going to plug in your x and your y value. It does not matter which one. There is no wrong answer to this as long as you do the correct math. I'm going to pick 2 because I like 2 best because it has all positive numbers. That does not mean 2 is the best option. That means that's the one I'm going to choose. So I'm going to plug in into problem 2. I'm going to plug in my x and my y that I already have. So that you're doing the same thing, and you can do 2 if you want to, or you can do 1 or 3. It does not matter. So I ended up with -6 for my x value. Sorry, for my y value. Did anyone do that in a different equation? You did it in the first one? You did it in which one, Reese? The first one? Okay, did you still end up with the same thing? You still get -6? Okay, good. So as long as we all get -6, we all did our math right. That's all that matters. So I got -6 for my y value. So my answer to this problem would be this ordered pair, 2, -6, 3. That means the intersections of these 3 planes, because that's what they are when you graph in 3 dimension. Each of these is a plane, is the ordered pair, ordered triple, 2, -6, 3.